Okay, we're on the last lesson for the first unit, U1A4. This is a short one. I said what I was going to do was I was going to keep each unit at 3.5 days approximately. So this is the second lesson of the second day. That means your third day, Wednesday, you have sort of off as a study day to get ready for your test. That's going to be on Thursday morning. Now remember, you don't have to keep up with my pacing in this course. I'm doing this to keep people on track who need this. If you can't get to everything during the first week and you do most of your work on weekends, be aware that I'm going through a unit about every 3.5 days. Now, one of the intentions of doing these videos is to draw you into the type of questions you can expect. For Unit 1A4, you're going to get two types of questions. You're either going to get something that is on the horizontal with a projectile motion, so like a cannon, and the next one is going to be off a cliff. So I'm just going to go through some reminders and try and answer a question here. So basically what's going on is we've got a cannon at a 45-degree angle and it's firing a cannonball at 30 meters per second. So we're going to get a projectile moving like this. Now, all I'm going to do is give you a bunch of reminders to keep straight for when you're answering the questions. First of all, there's two sets of formulas. If we're ever dealing with something in the x-axis, so going across on the horizontal, it's V equals D over T. If we are dealing with anything in the y-axis, these are the formulas here that you can use. So this is for when we're moving upwards. A few reminders that are extremely important. It doesn't matter where we are in this trip, the acceleration is always negative 9.8 meters per second squared, which is acceleration due to gravity. Now the velocity is going to slow down as we go higher until we approach zero, but the acceleration is always the same. When we calculate t from these formulas, we're calculating the time up to the top. To get the total time, you've got to double it to come back down. Next reminder, we need to get the velocities into the y and x axis. This velocity is on the angle. We need to split it up into y and x, and these are the formulas you're going to use. So we have a cannonball shooting off at 45 degrees, so sine of 45 times this hypotenuse here is going to be equal to about 21 meters per second. Because we used an angle of 45 degrees, we're going to get the exact same value over here. We are going to get 21 meters per second. Remember, I took the cos of 45, which is 0.707, and I timesed it by the hypotenuse, which is 30, to get those numbers. Now what we can do is we can start taking a look at getting some information out of here. So the first thing I want to do is I want to find the distance to the top. Now, if I'm going to do that, I am going to have to get a d value somewhere. So I'm going to use this formula here, Vf squared equals Vi squared plus 2AD. Your final velocity is going to be 0. 0 squared is 0. We have 21 for our initial velocity. So that's 441 plus 2 times our acceleration is negative 19.6 delta D. If I rearrange this, delta D equals negative 441 divided by negative 19.6. That's equal to 22.5 meters up. So that distance here is 22.5 meters. You cannot take this information and put it in this formula to get this distance. This is a scalar, it is a displacement. So we can't take that direction and put it on that one. We'll come to that later. Now the next piece of information I could come up with is the amount of time that this was in the air. I'm going to choose to use this formula here. if you use these ones here, you may end up with a quadratic. Actually, you know what? Let's try this formula right here. So we're going to go d equals VFT minus half AT squared. Now the reason I'm using this formula is I know this value here is going to be 0, so I'm not working with a quadratic. Because VF is 0, 0 times T is 0. So I've got 22.5 equals negative half AT squared. That's going to be 22.5, 19.6 T squared. T squared is equal to 1.14 seconds, and T is going to be equal to the square root of that. That's 1.06 seconds. Now remember, that's 1.06 seconds to the top, so we've got to multiply this by 2 to get the time for the total trip. Now the last calculation, and I didn't have to use that formula. I could have used a number of the other formulas there to get that answer. The last reminder I want to give you is I can now find the distance that this travels. I must use this formula right here. Distance equals velocity times time equals 21 meters per second times 2.12 seconds. Now, time is the only variable that we can switch back and forth between this formula and these formulas. And that's because time doesn't have a direction. It is a scalar. It allows us to take the time from over here and put it in this formula here. So what we have here is we've got approximately 42 meters that it traveled. This is part 1 of our calculations. Here comes our second calculation. Our second calculation is off of a cliff. One of the big things I want to remind you of is that this distance is negative 20 meters. That's going to make a difference. We must always split into the y and x. So you'll notice that we start with the same angle and the same velocity. So when we split this up, that's going to be 21 meters a second in this direction and 21 meters a second in this direction. Now, I want to remind you that no matter where we are on this travel or on this journey, we are always 21 meters a second in the x direction. And some of you might think, wow, this doesn't match up to the real world. And that's because of air resistance. We have air resistance which would slow this down. There's no air resistance in these problems. So no matter where we are always traveling at 21 meters per second in the x direction. Due to gravity, this is going to slow down to 0. Okay, so it's very important to note that. So in the y direction, when it gets to the top, it's going to be at 0. So if we wanted to ask a question, let's see what type of questions we can answer here. Or we can do VF squared equals VI squared plus 2AD. Now, what that's going to tell us is what our final velocity is in the y direction coming down. So this would be V equals the square root of VI squared plus 2AD. In the y direction, we are going 21 meters per second to start with. It's a positive value because it's going up, plus 2 times negative 9.8, and our distance is negative 20. Just a second while I'm doing the calculations. Folks, I'm going through the math part of this very quickly, so I'm hoping I'm not making too many errors as I'm going through here, but you can check my work for me. And once again, I am not being precise. I want you to show me that you understand the mechanics of how the problems work. That's my goal for you. I'm not looking at significant digits or preciseness here. Okay, so my final velocity in the y direction is 28.9 meters per second. My velocity in the x direction is 21 meters per second. Now, I want you to be aware, when this type of question is being asked, they might say, what's your final velocity in the y direction? They might say, what's your final velocity in the x direction? Or they might say, what's your final velocity? To get the final velocity, you have to use the following formulas. First of all, c equals the velocity in the x direction squared plus the velocity in the y direction squared, and then take the square root of that. So it would be 21 squared plus 28.9 squared, take the square of that. You would also have to get a theta value, and theta value is going to be equal to second function of tan opposite, which would be 28.9 over hypotenuse, which is 21. This is probably the most complicated thing that you have to do right here. Okay, so what you're going to have to figure out is how you get your VF, that was given right from the beginning, VFX, the VFY, which we did with this calculation here, and you're going to have to figure out how to get your final velocity altogether. Because when the projectile comes down, it's not going straight down and it's not going straight across. It's on an angle. So you have to figure out what the angle is, and you have to figure out what that C value or velocity is. Other than that, the questions are the same. Now, the only other reminder I want to give from yesterday is some people say, well, whoa, this projectile went way up in the air. So don't we have to calculate this distance up here to get the distance to do the problem? No, because what we're looking at is delta D, which is the distance from where the question began to where the question ended, and that's in the y direction. I hope these two samples were helpful. These are the types of samples you're going to have to be able to answer, sample questions you're going to have to be able to answer on your test.